Okay, we'll just give one more moment before we start. But just before I start the presentation, just as a quick note, if you guys have any questions, after the presentation, you can obviously like unmute yourself and talk. But you can also, just type in the chat as you go throughout the presentation, and I'd be happy to answer any questions. So I think we're ready to go. Looks like we are. So let me just get my screen shared, and we can get officially started. So, can you see my screen, by the way? You guys gotta click watch stream first.
Yeah, we can see it.
We can see it? Okay. All right, so I guess I'm good to go. So, yeah, I'm sure as you probably already learned by now, where this workshop will be, this presentation will be focused a bit on, learning about what AI is, what machine learning is, and the way I want to explain all this concept is through something known as YOLO, and it's you only look once, not live once. But basically, it's a special type of computer vision algorithm. So, how do we use cameras and how do we feed this into an AI system so that it just learns and understands the world around us? So, just to give a bit of an introduction about me. So I'm Shri. I'm 14, and so I'm in my first year of high school. If people are interested in where I go to the Woodlands Secondary School for the gifted program. I've built, algorithms such as, using like the CNNs to detect, cars and lanes when driving. I've detected, skin cancer. I've been also working on building my own self-driving car for the past little bit. But, today we're here to talk a bit about what YOLO is and how we can really use AI to perform object detection in real time. So, when we think object detection, we kind of think, like gun detection or maybe even theft detection, even like terrorist threat detection is something that's been implemented for quite a bit. And before I really get into, the technicals about, how cameras work and how we use cameras for this AI system, I want to talk a bit about machine learning. And basically, that being the overall focus of this presentation here. So machine learning, basically is a type of system that we use to help create some sort of AI model that can learn based on data. So we generally have three types of data. So we have something known as like supervised learning, we have something known as like unsupervised learning, and we have something known as reinforcement learning. So, let's just get started with supervised learning. And basically, we define supervised learning to be kind of like this. So let's say I had this data set of dogs and cats. And what you can kind of tell over here is I have like this labeled data set. So, so you have like this data set where like the left side of the data set is all dogs, images of dogs, and the right side is all images of cats. And what happens is as I have this data set, I feed this into this machine learning model. You can kind of think of it like a black box system for now, but basically what happens is we pass this data into the machine learning model, and what happens is in this model it doesn't learn, what makes a cat, what makes a dog a dog. It learns to generalize based on this data. So it might learn that dogs have like floppy ears, or like cats have lines coming out of the center of the image. I don't know. But basically, the machine learning model learns is through feature extraction. It learns what makes the dog, what makes the cat. So what happens is, let's say I bring in a new image. I bring a completely new image that this model has never seen before. And us humans can tell it's a dog. But what happens is now when we have this new picture, the machine learning model goes back, okay, let me remember what a dog is and what a cat is. And now using that data it learned from this input data over here, this data set over here, the machine learning model learns that okay, dogs have floppy ears, and now it's able to learn that maybe the output prediction is a dog. So that's what supervised learning is. Remember supervised learning, the TLDR being we have a labeled data set and we pass the data into this black box ML system where it learns. Unsupervised learning is a bit more different in a sense, but it's still very, it's still very intuitive and it's very understanding nonetheless. So let's say I had this data set, but this time what you notice here is that I didn't label the data set. There's no dogs, like dog side, and there's no cats. These are just random images of dogs and cats. So what happens is now I feed this into the machine learning model. But what happens is instead of telling me what's a dog and what's a cat, it learns to cluster data. So it learns to maybe group by certain features. So for example, over here, you might learn that class 0 that we defined this to be, class 0 has rectangular lines coming from the center. And class 1 has floppy rectangles that are on the sides of the face. And that's kind of just what unsupervised learning is. So instead of having this labeled data set, the model learns to generalize and cluster based on certain features and classes. Reinforcement learning is a bit different, but it's still, I personally think it's the most interesting of all the three types of ML. So reinforcement learning works like this. So let's say I'm a robot, and basically I'm put in this environment where there's just a bunch of dog and cat images. And the way this works is through something known as like a reward system. So what that basically means is, if you study, your parents might be happy for you or something like that. And that's kind of the same thing that's going on here. So basically we have the system over here where, let's say this reinforcement learning learns to classify based on certain features, just like unsupervised learning. And as it classifies, we give it like +5 points. So it's more like a gamification system, right? We gamify the process. And if the reinforcement learning gets it right, then we give it points. And this is like, going back over here where we talked about reward system, that's exactly what this is going on here. And then based on that, as we start to, continue to feature and perform this classification to separate classes, now we've created a reinforcement learning system that's able to do the intended action that we want through a reward. And generally, we use these three types of learning. We talked about supervised learning, we talked about unsupervised learning, and now we've talked a bit about reinforcement learning. But generally, when we talk about this stuff, there was something really interesting that popped along. And back in the 1990s, we use supervised learning generally as the main approach. Right? We'd have our labeled data set. Right? If you go back all the way over here, we had a labeled data set initially, and we'd always feed that into our machine learning model and use that to make predictions. But then all of a sudden, we had something known as deep learning come along. And this is exactly what completely revolutionized the AI space. So generally, when I talk about neural networks in the brain, we start off simple with neurons, right? And neurons have three main parts, right? We have the dendrite, we have the cell body, and we have the axon. So dendrite being, the input of the cell. So what that means is I might take in like an electrical input from another cell. And then what happens is that the cell body processes that input. Like, what does that mean? So kind of just, like for us, just like how I'm speaking to you, the dendrite would be like my audio that's coming from Discord, and the cell body would be you processing what I'm saying. And what happens is in the axon, you get your output. So for example, that might mean like, oh, I understand what Shree's saying, or it might be like, I have no idea what Shree's saying. But basically what's going on here is that we have our input, we process that input, and we get an output. So in the case of the biological systems, we have an input from an electrical impulse from another neuron, we process that input, and now we send out an output. So maybe should we output an electrical signal or should we not? And that's exactly what's going on with deep learning. So, going back over here where we had some sort of input, in this case, the dogs and cats might be our input. And what happens is just like here in the cell body where we process this data, the hidden layers exactly do that. We process this input data and we try to learn and generalize like what makes the dog, what makes the cat. And then based on that, now we get the axon which outputs something. And here in this case, I might output, what is the probability of this certain image being your dog, or what is the probability that, is this image a cat? So when we're talking YOLO, right, we're talking like image data, we're talking real-time object detection. So generally, the traditional neural network pipeline would not work because it's not computationally efficient. It just takes way too long for images to process. But we have something really special that we can use known as convolutional neural networks, and this is known as like a CNN. And this is exactly how we can use the AI to detect objects with YOLOs, understanding like the scenes, understanding the objects, the gun detection, the theft, whatever's going on. Generally, when we're talking convolutional neural networks or CNN, we have two main things. Like there are two pieces at the heart of CNNs. And the first one is known as convolutions. And basically what this means is I have this image over here. I have this GIF over here. You can kind of see we have this blue image over here. And basically what happens is I have this gray kernel. You can kind of think of it like a kernel. Or like a window. You can kind of think of it like a window. And what happens is I have this window that scans across the image. And as I scan across the image, I learn certain features. So I might learn what makes the dog, what makes the cat. And this is exactly where the AI learns. So we take something known as the dot product. And I'm not sure if you noticed over here, but we took this data and we put it over here. We made a new cell, right? And what you notice here is now we have a small input. Initially, we had like this 6x6 input, and now we get a 5x5. So what we basically do is, for example, this blue image over here could be pixel values, right? These are like pixel values of the image. So maybe like, white being 255, 0 being black and whatnot. So for example, if these are my pixel values of an image, just composed of zeros and ones, I'd have this certain kernel. So especially, what was going on here with this black kernel scanning across the image, this yellow would be my kernel with these, and each kernel has its own certain. So you can kind of think of it like a matrix. And basically here we have this matrix where it's like 1, 0, 1, 0, 1, 0, 1, 0, 1. And basically we multiply this by the actual image values. And as we do that, we now get a new output, which is 4. So we take the dot product addition. And basically we do like 1 times 1 plus 1 times 0 plus 1 times 1 plus 0 times 0 plus 1 What's 1 times 1? And we gotta just continue that process until we get the final convolution output. And what's really interesting is that this makes us a lot more computationally efficient, especially when we're doing real-time object detection, real-time like theft detection. We need to have extremely high FPS, so frames per second, because we want to make sure that we're able to detect someone who might pose some sort of risk to society. And what happens is when we make this image smaller, you notice over here, so we have this 5 by 5 input, but now we have 3 by 3 output. You see, we're able to make the image smaller while being able to learn certain features. So for example, if I had this image over here of a house, what you notice now is that given this house, now I'm able to, process this image through this convolution. This is what I get. And this is what the AI learns about the house. It learns that houses that have some sort of outline like this are houses. And what you notice here is that the reason why this system makes it more computationally efficient is look at it. So in the original image, we have a lot of noise, right? We have all these, we have like this roof, we have the shutters, we have like the grass over here, we have these trees, but the trees don't tell me what the house is, right? And what you notice is that these values also have an associated pixel value with them, right? And if you go back to like the dot product that we were just talking about, now having bigger numbers to perform dot product with makes it a lot more computationally not effective. Right? It makes it a lot more resourceful, especially with the output being that we have reduced efficiency or even FPS as an example. So now when you do something like this, now we have something that's a lot more computationally efficient. This is something the AI can digest. We get rid of all the unnecessary noise. Like the windows, I don't need the window to tell me that that's a house. Right? I can still tell that's a house without the windows or the grass or the trees. And this is how the AI learns. The other type of algorithm that we kind of use with the convolution is something known as max pooling. And what this basically means is, the name being pretty straightforward, we take the maximum value of a certain kernel. So here we have this blue kernel over here. And as the blue kernel scans across the image, it just takes the maximum value. So we have like 6, 3, 8, 8 respectively for each kernel it scans across. And what this basically does is we're able to reduce the size of the image drastically. And obviously going back to computational efficiency, this makes it a lot more computationally efficient for processing our input data, right? When we're talking about YOLO, when you're talking about we want really high frames per second, right? We want to be able to scan across the image and take generalized values to help make this a lot more computationally efficient. And one thing that was on my mind is like, why not just take the average of these values, right? Especially, with making this a lot more accurate. It sounds like taking the average value might make it a lot more accurate because now you're taking a generalized value of all the kernels. But what's really interesting is that max pooling generally works. And the reason why it works is because what's really interesting, like through various research studies that were conducted with respect to using AI systems, was the fact that max pooling seems to work because of the fact that taking a higher value is always better than having some sort of generalized value. So for example, if I have this image over here, I have this 120 by 120 pixel image of a line, and I compress this all the way down to 12 by 12 pixels. So that's almost 10 times smaller. And even though it does look not necessarily like a line but something else, you can still tell that this is some sort of line. And what happens is now when you pair the max pooling and now when you pair the convolutions, when you pair all of this together, you now get a convolutional neural network, and that's exactly what's going on here. So for example, I have this image over here. And basically, if I want to learn the differences between faces and cars and elephants and chairs, initially, when you perform the convolution the first time, I wouldn't be able to learn anything because it just recognizes this all as lines. But as you perform more and more convolutions, it learns higher level features, higher dimensional features. Like for example, it'll learn that there's a nose in the center of the face, or they're just like two circles sticking out in some sort of rectangle frame. And as we do that, we get higher and higher features where now we learn like, okay, this is the general outline of a face. If a certain input image matches some sort of outline like this, okay, then this is a face. Or else this might be a car, an elephant, or maybe even a chair. And now what happens is when we process all of this data, right, when we go back to CNNs, when you take the CNNs, when you take the convolution, when you take the max pooling, when you take all of this, now we're able to get the YOLO algorithm itself. And what happens here is that we have these convolution features, right? We have these convolutions that we have convolutions and our max pooling. What happens is as we do that, now we get certain outputs. So it's basically like our output predictions. So that's kind of what's going on. One thing that's really interesting is that we need to remember that we need to figure out how accurate our model is, right? We want to make sure that we have an accurate model, right? Is our model right? How well does our model perform in the first place? And generally, the easiest thing like you can think about is like, why not just take the overall accuracy? But the way accuracy works for real-time object detection is that if you get a single layer wrong, it automatically marks the whole object wrong. So I could get a really low accuracy with YOLO, even though I have made proper predictions. And generally, the reason why accuracy is in use is also because of the fact that it doesn't really tell me, it doesn't give me any insight as to how well the model performs. And that's exactly why we use something known as a loss function. And basically, what the loss function is, like the TLDR of what a loss function is that it's a metric to help figure out how right the model is, or how far away the model is from its actual correct, from how far it is from the actual ground truth. So, for example, if I had this image of a stop sign over here, right, this might be my predicted bounding box, this here outlined in red, and then the green might be my ground truth. Right, and what happens is now that I figured this out, I can see, okay, maybe my model was a bit wrong. You see, predicted towards the right side, and then now we're able to use the loss function. Or else, if you use accuracy, this will automatically mark it as a zero, because even though the AI model did something right and it learned something as it tried to process its data, it's still marked as wrong. So we get more insight using the the special type of a loss function we use is something known as IOU, or intersection over union. And basically, what this means is that we kind of take the area of overlap. So, for example, this over here would be my area of overlap, right? Wherever these red lines and green lines intersect, that's exactly where the model was right? This is our intersection over union. And based on that, now we divide it by like the total area. So if this was like my total area from this green diagonal to this red diagonal, you kind of think of it like with respect to like numerical values, maybe it's a one. And here you notice that wherever this red and green intersected, this black box over here, this is like a 0.85. So now what happens is now I have my IOU score to be 0.85, right? And now when I use those values, now that's able to tell me, okay, it's like I'm on the right track. Maybe I just need to, make certain tweaks to, if you go back all the way here to the way the model learned, maybe make certain tweaks to the way, facial features as an example work, or maybe make certain tweaks to like the stop sign text. Maybe I messed up the stop words wrong, and as it makes those tweaks, it's able to increase its accuracy and whatnot. So that's kind of what YOLO does, right? What happens is we scan across the image, just like with convolutions, we scan across the image, and what happens is as we scan across the image, we now able to make certain predictions, right? And what you notice here is that we have all these predictions that are just scattered and cluttered around. And that's exactly why we use something known as a confidence score. And that's kind of exactly what's going on over here. So when you say like predict one, predict two, predict three, that gives me a prediction as to where those objects are. But then I need a confidence score. Like how confident is my prediction in the first place, right? Because it's like you write a test, but you haven't studied properly. Like, okay, you wrote the test, but like you probably didn't do well because you weren't sure how well you did because you didn't even study in the first place. It's kind of the same thing here. It's like, how confident am I with my prediction? And that's exactly what happens over here is that based on certain confidence scores, now we're able to narrow this down. So from like a bunch of boxes that are going on in the image, we now narrow that down to three things, right? The dog, the bicycle, and the car. And yeah, here's just, a quick demo. I just went for a walk yesterday. So here's kind of just, a YOLO demo of me walking in real time. So what you notice here is that it detects the person in the first place. And then what happens is now I trained this specifically for like car detection. So what you notice over here is that the AI model is able to now detect cars with YOLO. So right, using that convolutions, using that max pooling, it breaks down the image, it learns all the features, and using that, it's able to figure out what's the car and what's not the car, maybe what's the person and whatnot. So yeah, that's kind of just to wrap this up. Thanks a lot for listening. If you want to learn more about me, if you want to connect with me, first of all, send me a Discord message. I have Twitter, which you might have seen already. Send me an email as well. Here's kind of my email address and my personal website. So yeah, hopefully everything makes sense. Just as like a quick recap of everything that we talked about. Supervised learning, remember, we have labeled data and we use that data feed into a model. Unsupervised learning, we don't have labeled data. We cluster into certain groups. Reinforcement learning is a trial and error, just like how a baby tries to walk, it tries to learn, and based on that, it improves its predictions. CNNs, convolutional neural networks. Convolutions, we scan the image, and as we scan the image, we make it more computationally efficient by reducing its size while learning features and representations of the actual image itself. Max pooling being, we just take the maximum value of a certain kernel. And remember, loss function being, how close we reach to the actual truth, and uh, IOU, intersection over union, where do our actual values overlap. So yeah, that's kind of a bit about me. Happy to take any questions right now. And yeah, if you guys have any questions, we'll type it in the chat. So Ankit is asking for the slides. Okay, here are just the slides. Give me a second, Ankit. I'll drop the slides in the Discord chat. So Yeah. While that's going on, anyone else have any questions? Okay. Yeah, I can give a bit about my journey and how I kind of got here. So I think a lot of things that I can kind of just say, like the way I really got interested in it was more of like through exploration, and that's kind of like what's going on with like the workshops that are going on today. We've had like Varsha to BCI, if you have like Anuraj to blockchain. We've had like Alan come in for like AR VR. And I think the main way you kind of just figure out what you're really interested in is just through exposure. And you want to learn about certain topics. Maybe if you're like really interested in AI, then maybe you'll watch like a video on what AI is, or maybe how to code your own AI. And I think the way you really figure out what you want to do or what you want to be is just through exploration. Like if you once you only like start putting yourself out there, once you really start figuring out what I want to do, you need to really start just exploring. Just watch like YouTube videos and maybe certain topics that interest you. But as you kind of just figure out what interests you, you kind of just really get into that habit of like, okay, I want to do this, and then you might come across a certain tutorial, and then you'll watch it, and then you'll learn something, and then from there you kind of just reiterate and reimprove until you become like a legitimate expert. Okay, so yeah, I can tell a bit about myself. So I'm actually really interested in self-driving cars. So that's kind of what I mentioned in the beginning of the presentation. So I've been working on self-driving cars for a little bit now. I've actually built my own self-driving car. Obviously, that was going to be tested on hardware, but like real self-driving hardware. But due to COVID circumstances, it has been delayed for now. But that's kind of what I've been really interested in. I'm interested in like the intersection between how can we use AI for autonomous vehicles. And I think the way I kind of got into it was just like what I've been saying before. It's like I got interested in AI from like a YouTube video, and then based on that, I just watched more YouTube videos, and I was like, okay, self-driving cars are cool. How do I get started? And then based on that, just doing some research, and based on that, just continuing the process, just doing exploration. And as I just do that, you become more competent, but then you find something that really interesting. So that's kind of where I'm at right now. With future plans, obviously I don't know where I plan to go. I think a lot of what I'm doing right now is just kind of like let me just explore these fields, see what I'm interested in, and based on that, just kind of focus on that. I think what's a really good mindset to have, it's kind of just general advice from me, but a really good mindset to have is like not necessarily be like tied down to something. And that's kind of what happens. Like what happens is that you should be ready to kind of let go of something. So not necessarily have like emotional attachment, but what might happen is you might be really interested about AI, and then all of a sudden you're like, okay, I want to be a BCI guy, but I don't want to do it, but I still want to do AI. But what happens now, you kind of have like that attachment there. But I think you should be really open to like exploration, and especially the idea of change itself is very interesting. So that's kind of what I would say.
Can I ask my question? I am audible.
Oh yeah, go ahead.
Yeah, actually, I don't have a question. I just wanted to request you, like, I have some project ideas in the future. If I wanted to work with you, will you be able to give me a option to work with you in your projects so that I can learn about more about AI and machine learning because I also have interest in that.
Yeah, okay, yeah, for sure. Am I echoing? No, I'm not echoing. Okay, no, yeah, I'm for sure. I mean, obviously, I'll drop my contact information. So just give me a second. You can always DM me on Discord generally. Um,
Yeah.
but but no. If I end up like not checking Discord sometimes, what happens is sometimes I just get
Yeah, no
busy and I don't
problem.
check. But here's kind of my email. I'll drop it in the chat. Even if I'm sure there might be someone there who's interested, but that's kind of my
Yeah.
email. So if you have any questions or anything, feel free to.
Yeah. Yeah, actually, I
Yeah.
have my in my mind some kind of project idea that actually I wanted to, but actually I don't have any person who can guide me like how to start. So I think I can take your help to begin my journey.
Yeah, I'd be happy to help. I think a lot of things. I think one thing to realize generally is if you if you really if you're really like really interested in AI, I think a lot of things that happens is that generally as you explore things, you kind of find tutorials and whatnot, right? And as you kind of go through those tutorials, you really just get an idea about like how I could do things. So I think generally help is always a good thing to take, but then again, like you want to make sure that when you're taking help, you don't necessarily ruin your own learning because if you kind of take everything from the other person, then you're not really learning for yourself, right?
Yeah, yeah, I understand.
So that's what I'd say. So yeah, nothing more to say. Anyone have any more questions? Feel free to just send me a message or just type something in the channel as well if you're interested. If you want to learn more about me as myself, happy to say anything. Okay, I guess there's no more questions. Anyway, thanks a lot for your time being here. I really hope you can learn something. I dropped the slides link in the chat by the way, and oh yeah, Arush has a question. So on the YOLO algorithm, what does the first try attempt, second attempt, and third attempt mean? So I'm not sure what you necessarily mean by attempt. If I understood this correctly, you can tell me in the chat. But what I'm thinking is you're meaning like I make the prediction, and if I get the wrong, like if I get the prediction wrong, like how do I take the second prediction again? So is that what you're trying to say? Oh, okay, yeah, that part. Basically, let me share my screen. Just give me a second. Uh, You can see my screen, right? Just now.
Yeah, we can see it.
Okay. Okay. So predict one, predict two, predict three. Basically, that's kind of what I've been talking about with the confidence score. So if you go all the way over here, this is kind of like the predict one, the predict two, predict three, right? So this is kind of like you know where all our predictions are, and then based on the on top of this prediction, we then have like something known as like a confidence score. That's not shown in the pipeline, but basically on top of the prediction, we have the confidence score, right? Like how confident am I with the prediction? So here these are like all the prediction one, prediction two, all the way to like whatever the prediction 1,000. I don't know how many there are, but based on that, a lot of them are like just like unconfident predictions or just like random predictions. Based on that confidence score, now we generalize them into three main groups or classes. Does that make sense? Yes, no. Oh, okay. Okay. Yeah, sounds good. Happy to. Oh, okay. Any other questions? No. Yes. No, I appreciate you guys being here. If you have any questions, just like I mentioned, I dropped my contact information in the chat. Obviously, for best first thing to do is Discord jam, but I sometimes don't check that. So I think I dropped my email. I'll repost it again. So this is my email. Send me an email if you have questions. Happy to help. This stuff is really interesting, and I'm sure you guys have fun here with the Innovire Summit. So yeah, take care.